So yesterday I got the gas material polished up and parameterized down the way I want it. And I've also gone through the work to basically load in the material interface here, create a dynamic material instance, set a value on it, and then set it to the Niagara components material interface, and that worked because I have this red color here when it's supposed to be like a pink color. I also did some optimization work. So unfortunately, there is some like graphic degradation. If you look really closely here, you can see like little square grids. So, this was really low performant, and it still is not great. But I changed the shading model to a 4x4 grid instead of a 1x1, which substantially sped it up. I was dropping to about 20 FPS or below 20 FPS in the middle of something like this, and now I'm at like a 40 or a 50. Still not amazing, but it's at least playable at that rate. And kind of the shading model becomes more apparent as you get further away. You can kind of tell that it's been gridded up, but it does speed it up quite substantially. It makes it not like hitch when I'm flying through it anymore. So now that we have all of those bits and pieces we're now in the easy part, which is just like basically randomizing all these values. So what do we want to do? Do we have a random stream here already? We can just take this, move it down to here. All right, so that means that what we can do now is, so these are set by f vector 4s. We can just, I'm thinking, I think what we would do would be stream frand, and that's going to be 0 to 1. And we just replace every color value with frand, and then normalize it. I don't know if I can normalize f vector 4. Shit. How does normalize work for a vector 4? 4, does it include the fourth vector component? Okay. So what we could instead do is we'll do vector color 1. Normal. Color 2 is the same, and then we'll just derive this. Can I do a vector 4 like this? I can. Nice. Nice and clean. So yeah, now what we're at is basically I have about 45 minutes here to do this. And we have this material, and we need to proceduralize it. So we'll go off of this. So these are all the values that we're going to want to proceduralize. Uh, let's do, okay, extent's an easy one. DM set scalar parameter value. Extent. This. Extent. But basically now we have, okay, we can just do this. Our material that's generating our gas appearance, and we want to randomize it so that every galaxy will get a unique gas cloud appearance. So let's see. We've got okay. So here's what I'm gonna do. I'm gonna check, and we're gonna check off the ones that we have proceduralized. Okay, so these are all set. I want to revisit this radial fall off because I think we can maybe increase our material efficiency a little bit further by reducing the size of the sprites and also reducing the radial fall off, because part of the problem is overdraw. So making the sprite smaller would mean less overdraw. Changing the radial fall off will cause the actual drawn portion of the sprite to be larger. So let's do hang on. We're going to want to change the name of things so that we have a consistent naming scheme here. So things like color balance that have a space. I just don't want any spaces. We'll do it like this. Particle color influence is fine. Opacity multiplier has a space. Just because, like, it's going to be easier for me to keep track of everything if we have a consistent naming of our scalar parameters that we're proceduralizing. Extent is already set. Base noise scale, no spaces. Distortion amount has a space. That'll probably run from like 0.02 to like 0.3 or something. Extent, and then position, scale, offset. All right. So we save this up. Save this up. Save this up. This is coming later. I am going to investigate some other gas cloud methods. So, position, scale, offset. We'll just go down the list. So what this basically does is offsets the noise sampling um, by some random amount so that it's not always like the same coordinate that we're sampling relative to local space of the noise, and then defines like an overall scale factor that scales everything. So for this, we would do FRAND range, I think. -1 to 1 on every axis. And then scale, we would do like, I don't know, 7.5 to 1.25 or something like that to start. And we'll have to tune all these values. Also, let's set the stuff that's not randomized up front. So that would be things like extent. All right, so back over here, let's check off our checklist. Check this. Base noise scale. Damn. Set scalar parameter value. Alright, here we go, here we go. So it's gonna be base noise scale. Rand range. For this, we would do like maybe 0.5 to 1.5 or something like that, and then we can actually just copy this. Set distortion noise scale. Noise scale. I'm pretty sure that's what it's called. Yep. This is currently at 0.4, so we'll do like 0.2 to 0.6. Okay. So now we have base noise scale, distortion noise scale. Done. We need distortion amount. And let's go with this from like 0.0 to 4 or something like that. It's this distortion amount. Color balance should be from like 1 to 3. Set the scalar. And this is all we got to do a proc harness for this material. Like, once you've built the material, that's the majority of the work. We'll do color balance from, let's do like 0.5 to 3.5. Basically, this modifies our noise going into the lerp. So it will change the balance between the two colors. Okay, color balance is there. Particle color influence, okay. So each star has its own color. Influence. And this value controls how much that affects the overall effect. And for this, we'll go from like 1 to like, I don't know, 0.9. And, okay, particle color influence, radial fall off. I want to revisit radial fall off, so we're just going to set it statically now. I'm not sure this one should change. Because we're just going to set it to what it's already at. But actually, I'm going to comment this out, and then we can just control this by, like, I may even get rid of radial fall off as a settable value on this thing, because like I said earlier, it comes into like an optimization question. If we can find a good balance of this and particle size, so if we reduce this fall off, then we can also reduce the particle size and cover a similar area with the texture. And reducing the particle sizes right now is the number one thing we can do to boost performance. So I want to touch these later. These two we've got to randomize too. So the last one would be opacity multiplier. Easy peasy. Opacity multiplier. And we will do for this one somewhere between 0.005 and like 0.04. 4. All right, and then how do we set the texture parameters? I'm just gonna get these set up and commented out. This would be bass noise, distortion noises still got a space. But I want to uh, randomly select from a selection of volume textures instead of just statically having two volume textures, and that's going to really drive up a bunch of diversity in the kind of appearance we get. So bass noise. To roulette select random volume textures here. Something like that. All right, so we can go ahead and test this. This alone, what we've done, should make a really large difference in the look and feel of each individual galaxy. So, hoping that this is a large improvement. I still want to investigate some other methods of rendering like the volumetric gas. This is just by far the easiest one to get off the ground because it just relies on the data that I'm already generating. But it's very expensive performance wise because of there's so many overlapping translucent objects that like overdraw is crazy and like the texture influence is crazy. Yeah, so there you go. We got a different gas cloud on this one. We'll go to a different one. All right, there's a little bit of work to be done here. Like clearly something's wrong in my globular generator settings. It's causing it to be able to like hit max bounds or something. Like something's up with that. But we have different colors. That's what we're looking for here. So what do we got here? Another one. I think maybe the individual star uh, contribution randomization is too high because we're getting a lot of just like a hodgepodge of colors, which is fine. We want to see that sometimes, but not on every galaxy. So maybe like instead of 0.9, we do like a 0.6 is the top end of that randomization range. Excuse me. Oh, gosh. It seemed like that globular worked just fine. I don't know why the other one was pushing out past the maximum bounds. Just don't have anything. That's another thing I gotta figure out. Like, occasionally, it won't spawn a galaxy. And I'm not sure why. Yeah, so I think we just have too much contribution here. Maybe go down from 0.9 to like a 0.6. And maybe go from like a 0.1 to like a 0. Just do 0 to 0.6 so that it is possible. Um, okay, next up, I want to compose an array of volume texture objects. I can randomly select from the set base and distortion noise for each galaxy. And we want to get the root node's color in here, actually. Um, so yeah, I think we can actually, hang on, color one. Initialize. Um, for parent color. 110, something like this, and then we can go out to universe actor, the spawn method. Where am I spawning my galaxy? Galaxy parent color equals and node. Wait, how did I calculate? Okay, that's like this. color, something like this, and then we can use that inside here. And hopefully that will make it have some matching on the parent color. So now when you're approaching like a dot in the overall universe that's red, it will balance out. And then also, I need my additive star sprite material here. And I think we were doing this. We can balance this a little bit heavier towards the multicolored side just for now. All right, let's try it. Okay, for instance, this is a blue. Oh, we didn't build. Or we haven't completed building yet. One or the other. Yeah. Failed. Range stream rate redefinition. Oh. Stream, random stream. Universe actor, I think. Oh, okay, so yeah, so it just goes get unit vector, then it calculates the rotation. So we actually don't need the second definition, and we're using it the same way it's used up here. All right. All right, all right. Changes. Let's try it. Find one that has a color. Okay, there's a greenish, bluish color. So now it should inherit that color. Oh, no, it just broke. Let's try a different one. It's like a reddish, purplish color. Okay, I think we're gonna have to spin it back up. I'm actually just gonna save, tear it down. Let's go see what happened here. U volume texture, T-ray, U volume texture. Okay, right here. T U volume texture. Noise textures. Yeah, but how do I load one of my textures into the array? Load objects. this example. Okay, we're gonna just comment all this out for now. I want to test the other changes we made. And this is going to be fiddly because it has to deal with paths, and we may want to actually pick the textures we're going to use and move them from like their respective plugin folders into the um, SVO plugin folder. Yo, what up, dude? We're so I got the gas material for the Galaxy optimized a little bit and kind of polished up, and now we're kind of parameterizing it and proceduralizing it. So hopefully we should reap quite a bit of like variance in the appearance from these changes of each galaxy, since the gas kind of determines like its colors and things like that. I still want to investigate some other methods of representing the math, like maybe some ray marching solutions, but for now, this is the easiest to implement, even though it's probably the least performant. But I have a couple ideas to try and increase the performance a little bit as well. All right, so you spawn our universe, find a galaxy. I'm hoping that it should derive its color, or at least one of its colors, from the parent node color now, if I did it right. Yeah, it definitely derives some of that green. I'm not sure if I put it in the right color though. Let's take a look at this like pinky purple one. Yeah, let's actually switch the color that's going into. So we'll just do color 1, parent color, something like that. Yeah, we're getting there. Unfortunately, so I don't know if you can see, but there's like kind of a little bit of a gridding artifact. It's very not performant because we have a ton of overlapping translucent spikes. So I changed the texture shading rate to 4x4, which means that like instead of shading every pixel, it's shading blocks of 4 pixels. And that made it at least not like slow down to a crawl. Or not like I was going like under 20 FPS going in the middle of the cloud. Like from the outside, it was fine. It was like 60 or something. But going inside of it, it would drop to like under 20, and now it's like 40, which is still not great, but like at least it's not under 20. You know what I'm saying? But yeah, I've just like we just passed the threshold where we proceduralize the gas so it doesn't look the same for every galaxy. I'm trying to get the color influence of the parent node to contribute to the gas cloud color. Yeah, like that. That might be a little too opaque. Uh, so I may need a little bit of work there on the randomization ranges for the opacity. Turn it down a smidge. Yeah, so now we're getting like a really nice contribution of the color of the parent node to the overall kind of gas color. And obviously, um, we have a lot of optimization performance stuff to look. Okay, and something about my like globular bounds and settings is making it so that it can occasionally surpass the maximum bounds of the octree. So I'm gonna have to figure that out too. That's just like the math in the core of that. But you can kind of see it when you see like these lines of stars. That's because it's trying to inject them outside the bounds of the tree and just going into the maximum point it could. But yeah, like once you're inside the galaxy, it kind of forms the colors of your night sky. Here's like a blue green. And we have a pretty good amount of variance now, I think. Like, they don't all just look the same anymore, which is really nice. And the cool thing about this system is that like we can go to any depth with this. Like if I wanted to add in like a star system, it could be attached to the same kind of parallax route and we just change the perceived scale of it. Oh, that's cool. And voila, everything should work. Also, sometimes it's not spawning, and I don't know why, so I gotta figure that out too. Like for that last one, it didn't spawn, or that one. So like obviously that's an issue. Or maybe it just errored out internally and now it's not spawning for any of them. I think it may have to do with the speed spawning constraints I put in. Like, I put in a constraint that it shouldn't spawn if it's over a certain scale or a speed like ratio. But I think I need like because it's like a it checks when it enters range, and once it's checked, it doesn't recheck. That might be the issue since it's like already checked it. You were going too fast to spawn, and then you slowed down, but like it already missed its chance to spawn. Maybe, but yeah, I'm pretty happy with the yeah. I'm pretty happy with the variants that we're getting now. And then also I have like you can see this one has like a lot more multicolored. So there's a setting that causes each individual cloud to inherit some amount of its star color. So like the way I generate these clouds is I like sample some of the stars. So like in this case, I'm sampling like maybe 0.05 0.5% of the total stars and adding a gas sprite to it. Um, and then I have a setting that will allow the gas clouds to inherit the star color they were spawned from by some amount, and then some amount is derived from like the randomized colors and the parent color. So if you roll a really high number on the star contribution value, then you'll get that kind of multicolored galaxy. Whereas if you roll a low color, like this is rolled a high color or a high value. So like a lot of the contribution is not from the like primary color assigned; it's from the star colors. Whereas if I'm sure if I cruise around here, eventually I'll find one. But this is like white, so it's gonna be white. Yeah, but it doesn't have the same variance because it rolled a low color, rolled a low number. Jesus Christ! But the last thing we got to do for the randomization of this is compose a list of the volume texture objects that we want to be able to select from, and then um, randomly generate which volume textures we're going to use, and that's going to increase variance by a whole lot more because now we would just be using like different noise patterns in our like it's a two noise. I use two volume noises One is a distortion noise, and one is just like a regular, like shaping out the the overall cloud shapes. So if I randomize which volume textures I use for that, it's gonna cause a lot of variance. It should look pretty nice. And then we're only really like a solar system spawner away from having our like little procedural universe that you can cruise around in and visit different stars and go down and stand on planets. Pretty cool. The cool thing about this is that this is all in like virtual coordinate space. So like I don't like the point cloud for these galaxies and the point cloud for the universe are actually pretty close to the same size, like in real space. It's just all controlled with parallax. So that has a bunch of benefits, and one of the benefits is that to represent this accurately, we would need a huge space where we would just not have precision on anything. Like it would be so big, you literally couldn't get precision on anything because everything is in centimeters and they're roughly the same size. We should, even on like individual stars inside a galaxy, not even like galaxies. Slow down. Well, maybe I spoke too soon because there's some precision problems. So I got to figure out why that's happening. Hmm. Okay. Eating my words instantly. Try another one. Maybe I'm too far from the origin. Um, find a star. Okay, here's one. I mean, I would assume if I was having them on that one, then I would have them on this one too. Yeah. So I'll have to figure that out. I think it might be because I've traveled so far from the origin of the universe. Um, so that would be like solved by rebasing. I don't know if it happens near the center of the galaxy. Let me find a star near the center. And if I'm getting jitters on the star near the center, then it's a local position bounds issue and my galaxy extent is too large. If I'm not getting it, but I am, so I think it's just an origin issue. Like so, origin shifting should fix it. If I were to restart back at 000. Oh yeah, yeah, for sure. I mean, like right now, this is kind of just proof of concept stage. Like, I would need to do work on the sprite materials and um, basically like increasing the range at which we detect the galaxies to spawn them in once I've optimized the spawning would let us fade the like sprite placeholder out from further away. Um, and I think that would do it. Like if instead of it's, I mean, I'll show you. Like, let's find here. We'll go to this one. Like if where'd it go? If instead of fading out from, hang on. Well, this one is small, so it actually works kind of the way that it's supposed to. But like instead of fading out from up close to it, it faded out like right now. It helps a little bit. And then like fixing some of the placement, like because the galaxies actually, at least the spiral, like the globular point cloud generator generates a perfectly centered point cloud around 0, 0, 0, but the spiral one doesn't. So it needs some form of an offset based on the equations that it's using. So figuring that out would help too, so that they like perfectly overlap, and then basically fading the heavily lit part out from further away so that it goes from like a twinkle to a galaxy before you get close enough to really see the change would be the ideal way to do it, I think. But I need to like optimize the galaxy generation so that it doesn't hitch, because like if I'm going to do that, it means that I potentially be generating like the further out we push the detection radius, the more galaxies we stand to generate in like a single pass. Because if we're detecting things further away, it means we could potentially have to be populating like more than one or two galaxies at a time. So like that would kind of come with optim. Like if this faded out right now and turned into a galaxy, then you and it was perfectly centered, you wouldn't really be able to tell. And then by the time you got close to it, it would have already faded out, and I would already be looking at the galaxy by the time I get like right here, right? So that's kind of the idea, but it will have to come after some optimization work. I think my high end of opacity multiplier is still too high in the randomization. High end of distortion effect might also be a little too high, but we'll figure that out. But like if I just like pick a spot inside this galaxy and look around, that's already a pretty nice skybox. It just needs like basically for me to face grind on it for a long time polishing it. All right. So, yeah, so like mainly the reason that it's so visible right now is because my search range to spawn these galaxies is pretty small. Um, if we pushed that out, maybe added some changes to like actually take the parent node size into calculation based on like how far away it should spawn at, so it's not just a one size fits all, but like a we pay attention to the size of the nodes we're scanning to figure, because like I could scan more nodes without a ton of expense. Like the node finding in the octree for finding the adjacent nodes. Um, I mean, we could be scanning, 100, 200 nodes, and that's not that expensive. But then we would need like a filter on that subset of nodes to figure out which ones are going to actually spawn galaxies, because spawning the galaxy is fucking expensive. So, like, maybe pare it down into a subset of 100 to 200 nodes by expanding the search radius, but then have like some kind of filter criteria on that subset to know what we're actually going to spawn, because like the galaxies spawn at a size that should fill the node size that is spawning them, but the node sizes are different. So like the fade in for a galaxy that spawned on a small node might be different than the fade in for a galaxy that spawned on a large node. Now, why is that yellow? I guess it's the color balance. Yeah, because it does have some of the blue in there, but the color balance must have rolled low. So let's change the translucency. 0. 0.4 too much, 0.03. And let's try to get this running. Because, like, what I want to do now. Okay, to do this, I think what we want to do is go up here, pre-baked 3D noise. So let's create a folder. Uh, volume textures, because we don't need all of the textures that we have. Um, we won't. This, this, this. Okay, so copy, paste. So we got this. We want this. Okay. Value turbulence. I don't think I want that one. We do want Voronoi. Move here. And then this one. It's fine. Move over here. Alright, so let's take a look. So we got this, 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 this. Let me go back into my material. I'm actually going to have to get up here in just a second and go to the vet. I got maybe 10 more minutes. So these will have to wait probably. Let me go see what I was picking from in the materials. Gradient, gradient turbulence. None of these. Perlin Worley. Values a no because it's very square and blockish. And Voronoi. I think that's it. So I think we're covered. Change the names back to make sense. These are the ones that produce the best like organic shapes. Yeah, I've been enjoying it. I really like the meta narrative of them just like fucking over Paramount after signing like a huge deal with them. It's pretty hilarious. Go to this yellow guy here. Yeah, so still need to address the scaling issue in my um, point cloud generator for globular clusters. Yeah, and like you could see the little hitch there. That's it, loading the galaxy. I have to figure out why, because like most of the calculation for that is off the main thread. I think it's just the assignment of the large arrays to Niagara that is causing it to hitch. So I got to figure out a good solution for that. Like maybe I need to stream it in instead of placing them all in place at the same time, but I don't know how to do that, so I'd have to figure that out. For now it's fine. Like I don't want to optimize too early. I want to get the system kind of working, then work on optimization. But oh, that's interesting. It's pretty cool actually. I think I'm still close enough to the center, to the origin, to where I'm not getting the jitter anymore. Where'd it go? There. Oh no, a little bit. So yeah, I gotta sort this out. So I'm definitely getting some precision issues that I wasn't seeing before. And it may just be like when I travel far away. Here, I'm gonna try it. This is the last thing I'm gonna do before going to the vet is shut this down. Maybe, unless it just crashes. Yeah, it's already heavily multi-threaded, but at some point you have to call set Niagara array. So like it generates all the arrays off the main thread, but at some point I have to assign the array to Niagara, and that's I believe where it's choking. It's either when I call set Niagara array or when I call activate on the particle system. One of those two, and I could probably figure that out with a little bit of debugging. But one of those two is causing the hitch, and I don't think those can be done off the game thread. Maybe setting the array could be set off the game thread, but I don't think activate can be called off the game thread. So maybe if setting array is the issue, then just being able to set it off the game thread might work. And then just calling activate on the game thread. Yeah, I'm still getting it. Weird. I swear I wasn't seeing this yesterday, or like at least maybe not yesterday, but okay. Well, I'll look into it. But it already kind of is multi-threaded, so where does this get invoked from? Initialize Niagara. Okay, okay. So this is getting called on the game thread. We could do everything except activate, maybe? What happens if I do this? Crazy idea. So, like, this is happening inside a separate thread already. What's this? I mean, it's not gonna hurt to attempt it. I mean, it probably won't work. But we can at least test it because if I could do all of this off of the game thread, it definitely doesn't would be better to do it not on the game thread. What I'm worried about is these invocations of like the Niagara activate. I'm pretty sure that's going to need to be on the game thread. It's going to freak out, but let's find out. All right, should find out here shortly. Yeah, I thought that might happen. But let's see where it aired out. Show call stack right here. Spawn system attached. So this has to be on the game thread. But we could conceivably. Okay. Yeah, we can. I think we can hopefully optimize this. But for now. Wait, what the fuck just happened? But for now, I need to go take my cat to the vet. So I will be back in a little while. Why is it freaking out? Oh, because I'm in the debugger? Yeah, that makes sense. All right, later.